Imagine an AI that can search the internet, write emails, remember your conversation, analyze documents, schedule meeting, even complete tasks automatically. Not just answer questions, actually do things. This is what AI agents are. And in this course, I'm gonna teach you how to build them from scratch. Hey everyone, welcome to this course. In this series, we are going to learn AI agents step by step in a simple and practical way. We will build AI assistants, research agent, voice agent, coding agent, automation system, and even automate AI workflow. You don't need to be an expert if you know basics computer usage and are willing to learn, and you can flow along. By the end of this course, you will understand how modern AI agents work and how to create your own real projects. What is an AI agent? So first, what exactly is an AI agent? A simple definition is this. An AI agent is a system that can understand information, make a decision, use tools, take actions, and work toward the goals. This is the key difference between a normal chatbot and an AI agent. A normal chatbot mainly responds to messages. You ask something, is answered. For example, what is the capital of Ethiopia? The chatbot replaces Addis Ababa. That's useful but limited. Now let's look at the AI agent. Suppose you say, check tomorrow weather and email me if it will rain. Now the AI is not just answering. It needs to search weather data, understand the forecast, remember your request, and wait until tomorrow and send an email automatically. This is an AI agent. It can act. Why AI agents are important? This is why AI agents are become such a huge topic right now. Because companies don't only want AI that talks, they want AI that works. Business want AI system that can automate customer support, analyze data, manage workflow, create reports, help employees, and save time. AI agents are basically become digital worker. The four main parts of an AI agent. Now let's understand the main building block of an AI agent. There are four core parts. The brain, the first is the brain. Usually this is a large language model, like also called an LLM. Example including model from OpenAI, Anthropic, and Google. The brain helps the agent understand the language, reason, plan, and generate a response. Think of this as the thinking systems. And part two, memory. Second is a memory. Memories allow the AI to remember information. There are two common types, short-term memory and long-term memory. This in short-term memory, this remember the current conversation. In long-term memory, this store information from later use. For example, your preference, previous tasks, project information, or important note. Without memory, the AI forget everything every time. And third part are tools. These are where AI agent become a powerful. A tool can be a calculator, web search, email sender, database, calendar, or even another AI systems. Instead of only generating text, that the AI can interact with real world. And final part is actions. Actions are what the AI can does. For example, sending email, creating files, searching the web, booking meeting, and analyzing documents. This is the major difference between passive and active AI. Now let's look at the AI agent workflow. Most of agent flow loop like this. There will be a user request, and then AI think, and then choose the tool, use the tool, and get a result, finally respond or continue. Let's use a real example. Suppose that users say, find the top AI startup this week and summarize them. What happens? First step, the AI understands the request. Then in step two, it decides it needs internet access. Then in step 3, it searches to the web. Then in step 4, it read information about it. And then step 5, it summarizes the result. Finally, it sends the final report. This entire process is the agent workflow. So where are AI agents being used today? Actually, almost everywhere. Example including customer support agent, they answer questions automatically. Research agent, they gather and summarize information. Coding assistants, they will help write and debug code. Sales agent, they manage leads and outreach. Also, productive assistants, they schedule meeting or organize tasks. Social media agent, they create and post automatically. This industry is growing extremely fast. In this course, we are not just learning theory. We are going to build real projects, something we will create including AI chat assistants, research agent, voice assistants, multi-agent system, coding agent, and autonomous AI workflow. We will also learn memory system, tool calling, APIs, vector database, and deployment. We will mainly use Python because it's one of the best language for AI development. We will also explore tools like LangChain, Crew AI, LangGraph, vector database, APIs, and modern AI models. But don't worry, I will explain everything step by step. I personally believe AI agents are going to completely change software, and the future software may not just wait for command. Instead, you give a goal and the AI figure out how to complete it. This is a massive shift. So that the introduction to AI agent in this next episode, so that we will learn important AI basics you must understand before building agent. We will cover LLMs, tokens, embeddings, APIs, context window, and more. If you enjoyed this video, subscribe, like the video, and comment what type of AI agent you want to build. Thank you for watching, and I will see you in the next video. Before we start building real AI agent, there are some important AI concepts you must understand first. Because if you skip these basics, you will eventually get confused when we work with APIs, memory, context window, embedding, RAG, or tool calling. So in this video, I will explain the most important AI fundamental in a very simple way with clear examples. And don't worry, you don't need a math background for this. Let's start with the most important concept. What is an LLM? LLM stands for Large Language Model. This is the brain behind modern AI system. Models like ChatGPT, Cloud, Gemini, and many others. All are large language models. A large language model is basically an AI trained on massive amounts of text, like books, websites, articles, codes, documents, conversation. The AI studies patterns in language. Then it learns how humans communicate. Here is something very important. The AI doesn't think like humans. It predicts the most likely next word based on patterns. For example, if I say, the sky is, you probably think blue. Why? Because your brain learned a language patterns. LLMs work similarly, but at a much larger scale. Let's see another example. If I type Python is a programming, the AI predicts language because it has seen the patterns millions of times. AI agents use LLMs as their reasoning engine. The LLM helps the agent understand tasks, plan actions, use tools, and generate response. Now let's talk about the tokens. This concept is extremely important. A model doesn't read a text exactly like human. Instead, they break into small pieces called tokens. The sentence AI agents are powerful might become a token like AI agents are powerful. Sometimes tokens are words, parts of words, numbers, or symbols. Every AI model has token limits. This means the AI can only see a certain amount of information at once. Imagine an AI model has a context window of 8,000 tokens. This means your message, previous message, instructions, and upload data all must fit inside that limit. Let's say real-world analogy. Think of tokens like human short-term memory. If you overload the AI with too much information, older information may disappear from context. This becomes very important when building an AI agent with memory, long conversation, document analysis, or RAG system. Now let's understand context window. A context window is the amount of information and element an AI model can remember at one time. Let's see one example. If the context window is small, the AI forgets older conversation parts faster. Here is a demo. Imagine talking to an AI for 3 hours. At some point, the AI may forget details from beginning because they no longer fit inside the context window. This is one reason why AI memory system exists. Developers build memory systems to help AI remember important information outside the context window. Now let's talk about prompts. A prompt is a simple the instruction you give the AI. Let's say the bad prompt example. Explain Python. Problem is the too vague. Let's see good example of prompt. Explain Python to a beginner using simple examples in less than 200 words. This is much clearer. Important lesson. The quality of your prompt strongly affects the quality of the AI output. What is system prompts? There is also something called a system prompt. This is a hidden instruction that controls the AI behaviors. Let's say example. You are a professional coding assistant, always explain code step by step. This changes how the AI behaves. Why this matter for AI agents? AI agents rely heavily on prompts. Prompts help agents to reason, make a decision, follow rules, and use tools correctly. What are embeddings? Now let's discuss about embeddings. This concept confuses many beginners, but it's actually simple. Embeddings are numerically representation of a meaning. Imagine this sentence: I love dogs. Dogs are amazing animals. This sentence uses different words, but they have similar meaning. The AI converts text into numbers called vectors. Texts with similar meaning are placed close together mathematically. Think of embeddings like coordinates on a map. Similar ideas on placed near to each other. Why embedding is matter? Embeddings are used in semantic search, recommendation systems, memory system, and RAG. Now let's discuss on one of the most important AI concepts today: RAG, Retrieval-Augmented Generation. What is RAG? RAG allows AI to search external information before answering. Without RAG, the AI only uses what it learned during training. With RAG, the AI can search documents, retrieve information, and answer using external knowledge. Imagine a company uploads PDFs, contracts, manuals, and internal documents. A RAG system allows employees to ask the questions like, what's our refund policy? The AI searches company document first, then answers. Why RAG is powerful? This is how many modern AI assistants work. RAG helps AI access up-to-date information, reduce hallucination, and work with private company data. Now let's talk about APIs. This is very important for developers. An API allows software system to communicate. Think about a restaurant waiter. You tell the waiter you order, the waiter sends the request to the kitchen, then brings back the food. An API works similarly. Let's see one example. Your app sends a message to an AI model using an API. The AI processes the request, then sends back to a response. Why this matter? An AI agent uses API constantly. For example, OpenAI API, weather APIs, search APIs, payment APIs, database APIs. Now let's discuss hallucination. This is when AI generates false or incorrect information. What means that? Let's see one example. If you ask the AI who won the 2013 World Cup, the AI might invent a new answer even though the event hasn't happened. AI models are prediction systems. They don't automatically know truth from falsehood. How developers reduce hallucinations? Developers reduce hallucinations using RAG, better prompt, validation system, and external tools. Another important concept is temperature. Temperature controls randomness. Okay, let's see low temperature. Low temperatures, more focused, more predictable, more consistent. Good for coding, business logic, and analysis. Let's see how about high temperature. High temperatures are more creative, more random, and less predictable. Good for storytelling, brainstorming, creative writing. So, why are these concepts important? Because modern AI agents combine all of them together. Example, agent flow. A research AI agent might receive a prompt, use an LLM, search document with embeddings, retrieve information using RAG, use API, story memory, and generate response. Important message: if you understand the basics, building AI agents become much easier. What we will build next? In upcoming video, we will move from theory into practical development. We will start building real AI agents, memory systems, tool calling system, and automation workflows. So that the AI foundation you need to before building AI agent, we cover LLMs, tokens, context window, prompts, embeddings, RAGs, API, hallucination, and temperature. These are the core building blocks behind modern AI system. In next episode, we will begin setting up our development environment and preparing to build our first AI agent. If you enjoyed this video, like, subscribe, and comment what a topic you want to next. Thank you for watching, and I will see you in the next episode. Hello guys, welcome to today tutorial. So today what we do, we just build the AI agent from scratch. So using API, we use a Qwen models and from OpenRouter. So we use APIs so to use the models, and we use a Python to create other things. So I'm trying to explain everything simply, and we cannot see each thing is on the code. So let's go on that. So the first thing is we use two things. The first one is we use a collabs to write the code and execute. So we can use it freely. So we don't need any GPU and other things. Just the free version is enough. And we use the open routers API, so you can find free credits. So that's enough for this testing and for this work. So you can go to OpenRouter, and I will put you the link in a comment, so you can find the link to sign up and you can get the API key. So first, let me show you how you can do that. So here is the in OpenRouter page, so you can find the different models. So here is lot of you can search. Let's search Qwen. So we use a Qwen. We have a lot of models, but for now we use a Qwen 3.6 flash. So that's enough for our work case. So let's search for Qwen 3.6 flash. So what we do, how we can create API. So here is a documentation, and you can find this API creating link. So you can click this one and takes you here. So I do have some API keys, so you can create a new one here. So you give a name, and here is a credit limit. You don't have to put that, just give a name, and then you can put the expiration date, and that's not necessary. So just you can create here. So you can and take the copy and the paste somewhere to put permanently, so you can find it again. So you have to do that, and then what you do, you will pairing the APIs key here. So on a collab secret, so we add that on this area. So you can add by clicking this add new secret key and give the name. So for example, here is the name, for example, main API or something like that, and paste the API keys that copy from here from this OpenRouter. So this part is for beginners, so you who don't know how to add the API key and no experience with the Google Colab environment. So you can do that, and you can turn on this one after adding the key. So this is guaranteed to access this notebook, this API key. So here's how to load this API key. So you can safely load your API key. So here is we do first thing is just we call our API keys. So this is the name of it. So we did it. So you can do that. So I will put this notebook on GitHub so you can find it. So don't worry for that. So first, just let's do simple test. Just what is that? We go to OpenRouter on Qwen 3.6 flash model documentation. So you can see other things like different performance and comparison. So you can find it here, so you can read about this one. Just that's not what I'm looking for now. So just we can use OpenRouter CDK, and we can use on OpenAI CDK, and today we do just raw one. So we use a Python. So just we call just APIs through web request. So we do that. So what we do now, just here is the example. We can take a copy and paste this one there. So what we do just to get a response, we request.post. This is the complete OpenRouter's link, so we have to put every time this one. This is just the command for all models. So, and then here is the for authentication. So we have to give the OpenRouter API key here, and this is just the format of the response. So it is just the JSON format. So what we do, just already I have here. Let me copy this one. I mean, I can take that from here. Let's bring this one. So let's take this one. So when we call this, just this one, we can't get any response. Just we got a error. So we have to let's see the response. We do just detail it, so you have to look properly. So let's see the response. When we see the response, just we get this error. So we have to I defined the my API key. So let's try to API key. And another thing is we have to add the max token. So I have to okay, we did it. Let's see what the response. Still we're getting error. Sorry for we have a problem. So let's see the response. Okay, the response is okay, so we can okay, we got it. Great. So what we do now, we have this kind of response. Just this is API response. We get it. So I think this part is clear. So this is the URL, and we have to put every time. We are doing just web request, so we have to put this, and this means like your phone number or your Gmail address. So, and this is just to address who are you, the API, and this is just what we give the what we are asking for this model. This is the name of model, and here is the chart. We give what our prompt is. This one is a prompt is. So what we do here is just this is reasoning. So we can do true or false. So we can allow to reason, or we can make it just uh, you know no reasoning for answer, or we can do that. So that's so let's define this. Let's give a name, response data. So what we do, we have a lot of data. We have to extract only the answer part is, so we can do that. And just to understand how the response, we can see we have ID. This is for open routers, and the model name, and this is like a metadata service. And here we have our data is chose, and here is some metadata. We don't need that. We go to this message part, and we take this content. This was our sent it message. That means our prompt, and this is reasoning, and here is the reason, and here is reasoning detail, and here is data case on a reasoning detail. We don't need that too. So here there is a lot of things: completion token, total tokens, costs, and you can find a lot of things: video tokens, audio tokens. So I think this is a detailed data. So what we are looking for, we are looking for the message part. So how we can extract this? If you are familiar with list and the dictionary on Python, you can do that easily. So let's see. Dot keys to see how many keys we have. So we have ID, object, created, model, provided. So we take this one, this choice part. So let's take the choice and choice part. Let's see what we have. So in this part, we have a listed data on list. So we have to take 0 because only one listed value we have. So we get a dictionary. Now we can ask the keys. What are the keys? So we have index, log, props, finish reason, native, finish reason, and let's take this message. Go to message, and let's see how it look like the message. So role is a stamp, content is okay. Then this. So let's see what was the question. How many? Okay. Phones. I think we missed something. Sorry here. So let's see. Okay, here is our question was how many artists in the world of strawberry? So refusal is none, reasoning is reasoning, and the answer question is how many this is. Let's take this content part, but I don't know why it's answered. Okay, there is, so we take this content. Our answer is in content, so we take this content. This is there is 3 arrays in the world of strawberry. So that's it. So what we do now, which we can look also the reasoning part too. So because we can, let's see, so reasoning detail, here is reasoning and here is reasoning detail. Let's see, for example, reasoning part. And we can see as a markdown format like other web page. So markdown, let's print with markdown. So now it's easy to read, and I think this is the correct format. So because of our output, we get the output as a markdown format. So we can use this markdown to print it. So here is the reasoning detail. So I don't go to on that. So this is just to call and get it model response. Just this is where just how to use a OpenRouter API. So this is a simple example. We take from this so let's so we do try to collect the history. So what we do now, this is our response, the message part. So we can take from message the content. So what we did here last time, the content part, and then we take the reasoning detail part. So this is the response data from last one. and we do new call. Here we add max token. We have to add here max tokens equal to 500. It's enough for now. And what we are asking new questions. Yeah. Are you sure? Think carefully. We are asking again about what? About this answer. So this is unmodified reasoning from output from the last call. So that's there's no complication here. So let's call it and let's see the response to. So we carried. Let's check it. Okay. .json. So sorry, we have to add the navigation part. We have to add header part before we need to add this header part. Okay. Hold on. Sorry for this we are doing second time, so we can do that. Just let's comment it for now. So let's see it. Yeah, we get an answer. I think so. We come to here and message and we take this part. So this is our answer. Yes, I'm sure if you break down the spelling, there is exactly 3 arrays in scroll. So this is how the memory works. Let's try without memory. So when we add a memory, we add it in the memory here. So we can comment this one, or we can cancel out this part. I think this is the answer, and we can remove this all. We have to remove this with a question, okay, and the answer. Let's try now what happened. I think it asks, yeah, it asks us to what about the we are talking about. We doesn't have any key, so what is this reasoning part? This is content part, so I'm not sure what to be sure about, and could you please provide a specification? So this is the memory, importance of memory. So this is uh, how the chat history or how the memory is so important. And we know we use all time on ChatGPT when we try to write, and we create a chat history. So the chat history takes our question and answer, question and again answer. So that's way it's work. So this is a basic thing to you have to understand. Next, we can go to I think this is not actual agent, but let's try to more like a ChatGPT way. That means we can use a while loop to create a loop way. So let's try this thing is here. So in this one, this code is the same, but we create a loop. So if you are familiar with Python, you know how the while loop is work. So what is it try to keep things in loop until we enter the quite or exit text. So when get these things, it break the loop. So here is the thing is just we define the chat here empty list. So we collect the chat history whenever we get a input from users. We append on our chat history list, and we call API call here, the same thing as we did, and we give a chat history. So we get the answer, we get the prompt, and here is our prompt, and we give to AI model. So we get answer if the answer response is okay. When we get the response okay, and just change it to JSON, then we try to extract the message content part. So you know that. So we collect the as message content, that means output of the AI model, and then we print here what the answer was from we get from AI model. And here is the thing is what we are doing. Just we have this assistance, I mean the output of AI model. We give to chat history to make his memory for AI models. So we give this for that, and except we it tries a error, and this else work with this one. So for this block, so whenever we get, if the response is not okay or we have a problem with APIs, we get the API errors. And whenever we get any thing is on a API call here, we get this error. So network or some issue with API. So, and what we do now here is just to remove the last value or elements from list whenever we get errors. That's keep the clean memory. So this is so important. Let's try this one. So how we can check? First time, just let's we allow to collect the memory here, and let's see what happened. I have a text, a small text. Let me take it. Okay, let me tell about myself. I am Isaac, and I'm Isaac, and I have 7, let's say, and let me give I'm Isaac, and from Addis Ababa. Let's say, so I'm giving about myself, and we check the history. So this is a simple thing. So it's now my name, and we get the answer. So how you see on ChatGPT every day. So let's ask what is my name and where I am. So if answer correctly, so our memory is working. So your name is Isaac, and you are from Addis Ababa. How can I help you? So this is how the memories work. So let's enter okay, and let's try to no memory. So what we do now, there is two ways to collect the memory. Here is the first one is our input, our prompt. This is collecting every time when we give a prompt, just it's collecting as information, and so we can collect our in prompt and the response. So two ways we can check. So first thing is when I give information. Let's try this one. What we do, we uncomment this one. Every loop, just the chat is new, or we don't have any history about any previous chats, so any response and any last prompt. So let's try this one. So my name is again from Addis Ababa. Let's see. Okay, you know my name now, but let me ask, what is my where am we expect, I don't actually know your name. Where are you from? Privacy keys. I don't have access personally. So this is the importance of the memories. So let's go at these things. I think this is quite clear now. Quite. So what we try now, we test real AI agent. Now this is not AI agent, so we miss one thing is that's called tools. So whenever need any external information like wizard data, API call, other API like models or something like any data from other APIs or web search or news search. So we do for now just simple API a function calling. So we give a calculator and wizard. That's simply mock wizard function. So how these things work. So this is defined. It's determined to call the wizard function or calculator function whenever needed that. Otherwise, it depends only on trained data or it doesn't call any APIs. I mean a function. So here is things and just let me explain. This is a function to use a calculator. So it takes the expression, the argument I mean argument and response whenever needed to these calculator functions. And for now we have only calculator function available tools, and we gonna add the gateways there after testing the calculator one. And total tools schemes here is we define how it should use this when call a function, it should understand what the function takes and how it's work and what's the name, and that kind of thing is just the description. So here is the name of here is a type is a function, and function name, calculate, description, and parameters, type, object, what type of, it can be integer or object or something like that, Python data types, and property and expression, and type is a string, and a description. Here is the math expression to solve, example, this, and use that kind of thing. So this is the, to help to, define the JSON schemes to LLMs to understand it. And we will have a chart history. Already we give one chart history. We give the prompt is here. Anyway, let's come here, agentic system type and quad. Here is the loop, I mean while loop. So this is the same thing. And here is what's the difference, only we are now trying to use a tools. So here is the same thing, and we add a tools, we just pass that tool scheme. So it will take this dictionary and understand about our functions. And so this part is the same thing. There is no new thing is here. And I think here is we have to understand. So if tool calls in message data or message tool calls, so when we get the response from AI model, so we do this is just a for loop. So here we call a loop this, I think we call a max loop. So here is a loop. So we are doing a loop. So max loop is 5. So the AI model try to for maximum 5 times. So it can try for 5 max, at most 5 times. So here is it get a response. In a response, it extract the tool calls. If tool calls is in a message data and message data tool calls, the chart is append the message data, that means just for memory. And what it does just for tool calls and message tool calls, so try to loop on all message tool calls. For example, if we are trying to call 2 calls or 3 calls, we do for loop. So we take the function name from that. So tool name is like calculator or whether data or tool arguments. We take the argument that function takes and ID, and here is print the tool name is and argument is. That's it. We get this response from AI model. So this is we get it from this response from AI model. So this time just AI is determine what tool it's gonna use, or doesn't need AI, tools. It work by itself. So this thing is work that way. And if tool name in available tools, it should be in available tools for now. So we defined it here. So for now we have only calculators. Here it is. For now we have only calculators. So we check if that thing is to before executing. So after that, just we get the function, result from the on the execution. So here is the result we get here. So if not, the tool name is in registered locally, we get an error. And here we do just add this on our history. And this thing is continue atmosphere 5 times. And then we get the message content, no tool were requested. That means if we don't need it doesn't need a tools, just we get the raw answer from a model without any tools. So we get there. We do append also the answers. So let's try this thing is what we do first. We try to calculate these numbers. What is this question? So let's try and then let's see what append. So let's input our prompt is. So agent thought I need to use calculator tool with argument expression arrays. This is the name of tools and this is the expression. We get this from a and tool output is this one and agent output is this one. So this is a correct answer. This is just to verify. So we did that, and let's ask this thing is another question. What is the ways like in Addis Ababa right now? Let's respond. It may respond something like, I don't have access to real-time information, so I can provide a current weather condition at Addis Ababa. So let's try to add weather functions. So here is just this is a mock one. Just we get a city, and if London, the responses will be 15. If Tokyo, 22. If Addis Ababa, 24. So just this is mock one. So we can replace this with real one. For now, we take this one. We have to curate this one before that. So let's come here. Let's add this function. And plus, we have to give this description of our function. Otherwise, model that cannot call properly our functions. So let's add this one here. And plus, we have to uncomment this one. This is name of our function. So get wizard. We have to uncomment it on available calls because it checks finally if this only call if the tool name is available in this tool name. So let's try. Let's ask the question that again. So I need to use get. Okay, get wizard tool is used, and here is the argument. This give to location is Addis Ababa. We get 24 and beautifully sunny. So we can change this to other like London or something. London. Let's try to London or Tokyo. Let's try to ask Accra. I think I'm. Let's try to. So okay, right now we get what the function. Earth return 18 degrees. So if we get 18 degrees, so we get 18 degrees. So that's our work the AI, tool calling. So we learned it all about the tool and memory. So
you can go back that video to understand what means tools and that basic fundamental definition and understanding. You can go and see the playlist agentic full course, so you can find the basic definitions and what's you know the basic terms and definition. You can find that things, and I will put the Discord on GitHub, and also I will put on Kaggle too, and so you can find it, and I will put the link on comments, both OpenRouter and Discord. And next time we go more advanced one, just we do real API calls from different wizards and news and different kind of things, and we use more advanced way. I hope this is clear, and you know I hope you understand everything. So like bye.
Hey guys, welcome back. To this part today we see RAG with Chroma and we use Qwen models. So last tutorial we did on a basic AI agent. So we did how to use APIs to call LLM model, and then we did some memory, and then we did how to call a tool. So now we use a RAG, and we're gonna see how RAGs work and how LLM uh, work with RAG to make more accurate the response. So we use a Chroma database. So if you don't have any experience with Chroma, you can find the Chroma page and you can learn about Chroma. So Chroma is a vector database. So we use it, and we use OpenAI or to call the LLM model from OpenRouters, and we use this is not important for now. So this is two package we have to install, and I told you last video, so how we can get API key from OpenRouters, or we can use different uh, APIs from Gemini or from OpenAI. So for this tutorial, I'm using from OpenRouters, and so we have to install this. So let's install this package. I think I already ran this. Let me restart the season. So Chroma store documents in collection and lets you add text with unique ID and a query similar. So here we load our API keys, and here we import some packages. So for this time, this is not necessary. We use OpenAI to call our OpenRouter. So we give both our head API key and OpenRouter address. The loss. Let's define as a client, and so so we use a Chroma. So Chroma is open source data infrastructure for AI. It comes to everything. So we use this to store our data in after we embed our text. This is just for example, we use this doc text. So we have I think 5 documents. So this is the first document. So just this is for example. So we have students and this about that. So we have one list, and we give a ID for our document. This is so important. We need to understand this part. So we have 5 documents. So I mean I think 4 documents. We have also ID. So we add our collection. So our collection we define it here. Like, so let's find. We have to define first. Otherwise we can't. Okay, we have to take this one. Let's run this one. We can create a Chrome client. So we give that, I mean, a pass, and then we create. This is try to delete any previous collection data from our environment, and we create here agents node. Name of the our collection is agent nodes. Let's add our document is onto our collections. So here is the main thing is we have to understand when we use vector database. So embedding models are models that use take a text, for example, take this sentence and then convert this onto numbers. So when we see the numbers are when similar words has a close, there are similar numbers or close each other, and chunking is just strategy very unique to the data. This is for large data. When we have large of data, we have to create a chunk to get a more unique. And when we have, the context links, we learned about the context links. Every model has a limitation when we take input data and give output data. So when we give a lot of data, we can give at the one time. So at the one time, so we have to reduce our input. So chunking is help to create revalent parties by splitting the in a larger text. So that's and the result is just number of result balance token using with correctness. So most likely this is just when we get the when it retrieve any information about our inputs with a number of contexts. For example, we have a four documents here. We have a four documents. So the first one is this one. So this is about student Leo, and document two is school policy. So this is about school policy, and we can have a lot of thousand or million data like this. It may uh, wide from this one, so we can have a PDF and books, different kind of data, and so when we ask some question about our data, or when we try to use a LLM, so what we do, we ask something, for example, what color does Leo Milner Pete Cameron when he's sitting on his backpack? So we are asking this is a specific question. LLM cannot find this kind of data anywhere. So we use RAG. So we are using RAG for that. So what we do, what we are doing, this is our prompt. This question is a prompt, and we give it the same thing as for LLM and for our Chroma database. We have a collection. So from collection, we query our questions. So when we do that, we get the pop answer only one. So we can change this one to any number. So for this time, we take only one the first rank document. So let's see what we get. Let's see, there is a school. This is name of uh, document. So the school students. So that's correct data. We need to answer for this question. So what we are doing here is a lot of things. What we get, for example, let's see what we have a keys on our result is. Okay, keys. So IDs. So this is ID what we give. Embedding is that is a numerical. When LLM models change our text into numbers and documents, what we use for we give it as a context for LLM models, and this is other metadata. Distance is how close each other. So this is the main thing. This is our what's the distance between our text question and each document is. So we the Chrome database when we query this try to see which one is more close for our questions from collected data. So let's change this one, two, because we can have a two documents. So let's see, for example, let's come here. We can have two documents. So the first one is school student and school events. So this school events are second documents for us, but that's not valid. So let's see the distance. So this one is closer than this one. For example, let's say our question is one. So the correlation is for one is this one is more closer, and this is far, far from this one. So this is how the retrieving works when we use a vector database. So we can change these numbers based on our data. For example, when we have a lot of data, lot of revalent data, we can take best revalent one. So for now, one is enough. We can take a lot of based on our input size and the document our document type. So for now, we can have only one. So only this one. This is enough for to answer our question. Our question is, here is the question. What color does Leo Miller paint Chameleon turned when sitting on his backpack? So our question is that, and we got a context, so we collect on this variables. We join it to remove any. When we get two or three documents, we have to join them, and then let's go to them. So let's ask without any context. So this is a system prompt to this is instruction for a model. You are a helpful AI agent teacher. Answer the user's question using only provide text. So we are strictly grounding when answer questions only on a given context. So if the answer is not in context, say you don't know. So let's say remove this one. Let's remove this one. Let's constant case and let's ask what we get. Probably we get. So I don't know. So the model is working correctly. Let's add our context. You can see our context is this one is document one based on our here is school student and category student profile. So this is a context we are giving for LLM model. So let's run this again and let's try to use LLM. So now we got a correct answer and turns bright blue when it's sit on his backpack. So this is the simple example how RAGs work helps the LLM models in different, specifically on a more specialized area like medical and different company data. So we can use that way. So this is just a simple and uh, first example to understand how the RAG works. So whenever we use LLM models, we can use this RAG. For example, when we use a lot of chat history, when we have a lot of chat history, we collect on a vector database and LLMs every time when take our prompts and try to find in the revalent chat history the best one or revalent one. So text top of them and answer what we need. So we know when we use ChatGPT or Gemini and Cloud, our chat history LLM model currently understand what we are talking about. So because of the rack. So let's go to the next part. What's happening? So when we hack the out, for example, let's go to Gemini. When I ask myself, what's my name? What is my name? So LLM already tried. I don't know. I don't have any name in my. I don't know. So it has some information about my projects and but I didn't tell anything about my actually I didn't tell about my name. So just this is trying to take this prompt and then do some rag on my documents and find relevant you know correct response. So take the questions and then search Chroma just database and get relevant questions. That means relevant documents based like this. So try to find if our question is this one, try to find best relevant one. So we take some relevant information and put the document into in prompt as a context, then Qwen models answer using that context. So this is what happening now, what we did. So let's go to chunking. So when we have a big file, so in a real project, mostly we get big files or big documents like if we are trying to use this book as a for rack. So this book is so big to give just as one document. So what we do, so we try to chunk them. So just splitting the our text in some parts. So we take, for example, let's see small text. We take only 5 text, and then it's one is overlap. So it takes it our text there. Try and it's work until our text starts being less than two text. So try to split things. Let me show example to understand. Let's take this up and we take this text. Let's see. So we created a lot of documents from this one sentence, almost one sentence. So this is just take only four characters. So this is how the chunking works. When we have a lot of big files, so we can chunk them. We have to chunk them to get the relevant from all. The size of input LLM inputs are matter and determine our inputs. So we have to limit our inputs because we are giving our context with prompts. So LLM models doesn't have, it doesn't have a memory by itself. Just we give a context. Our memories are our context, so we have to limit that things. So this is important for that case, and also chunk size and overlap is so important. We can see that why that's important. Okay, let's remove this. So we have to delete the previous one, and we have to create new collections. And here is some example of file. What we are doing here, just this is not a big file, but just for example, we take this and try to how much the chunk size and overlap is so important. So let's see. Let's try to split these things. What we do, let's take this answer cell. So let's see, for example, let's see the first chunk is this one, living, and this part up to, you know, answer something like that, self-expression, unit, counter development, and predictive. So answer the following question before you read use picture and something like that. Here is uh, this is a main table contents, and here is a section 3, reading and lesson, pre-reading, and answer the following question before you reading picture, so guide, and was something like that. LLM cannot answer this question without reading the paragraphs, and when we see this one, when we try to chunk, sometimes some information is split, and we may miss the information. So, for example, for this data, the the best part is to split is here on this part, but we can't now that. So the problem, this is the, we have to, find the best chunk size and the overlap when we do this kind of route, when we do chunk on, because, let's see the document too. So when we give this only from as a context, we may lose the main parts, titles. What about these things? So we may lose that kind of thing. So we have to use more overlap. If we try to improve the overlap size, we can get more correct and correct context for AI models we can give. So let's try it now. So it include all parties. So this is more complete than previous one. So overlap size and the context size is so important. We have to find, find the best threshold for that. If go in the case, let's go to this chunk, all of these things. And then here, let's add our chunk is on, sorry, on our collection. Just this is loop to create the ID, so we can create easily our document IDs. So we have to, uh, put all knowledge directly inside in the prompt. That make the problem in the input size of, context size. So that's limit. So we have to store knowledge in Chroma and retrieve only relevant chunk and send those chunk to the model. So what we do every time. This is what we do every time. So next, let us ask one question. What's all unit list? Say, let's ask this question. List all unit. So we are, to get that, we have to, we take only best result one, rank one, and our question is list all units. So let's see which document are correct or more relevant for this. So this distance size. So we can see this one. Let's see 3. We take top 3. Let's see the distance. This is 1.4, this is 1.7, this is 1.8. So the best one is just, let's take the top one. And what we do, just we take the document part and we join them. And here is our system prompt. This is the same. We didn't change anything here. Just the, for this time we don't have the context part. So if we ask only, we are taking a system prompt and user prompt doesn't, it didn't contain any context. So when we asked with this thing is, we got an error. So already we did say, our system prompt only answer based on prevalent or provided text. So the model really ask, oh no, I don't know, please provide any reference. So let's give context. Context is context. So now let's see our prompt. So we got a question and context LLM easily answer our questions. So table contents, this is our context, and here is our question. Where is the question? You can find there. Oh, here is the question. Here is the question. So we are giving this for LLM. So there is no magic here. Just our user prompt in part one. This is a system prompt. Let's see. Guarantee. So this is a correct answer. If we got a we split sometimes when we do when we check. Let's come here and let's reduce the chunk size. If we take only 100 or 300, we may lose some parts. Let's see what will happen. Run. So still it could find. So let's see what the context. Think we did give full context. Already we give full context. Let's try to see reduce the context as what can happen. Let's take this to 150. Or will be 100 overlap size. So let's see context here. So I think still the context is included all parts, so the LLM can find, but we miss some parts. We give from chapter started from chapter 5, so the best. So we get if we improve this part, so what we get, just we get this answer. So LLM is only based on revalue or context, so we can when there are this kind of issue, just we can improve this part. We can include 3 documents. Let's see now. Still we miss some part. Let's see what are our okay, there is no any information about chapter 1 to 4. We have to include them. So this is a part of the chunking. So our chunk size depend on our technique. We have to find the best numbers. So that's so important. So let's ask one question. I want to ask one question from here. This part, I think this is a really good question. I should read this part to answer the question, these questions. So let's ask first why. So what's right true if simple based on all reading passage. So let's ask question, this question. Let's come to here. We have to adjust this size. This should be 500. This should be 200. And where is question? Question will be we have to run this part again, this part. Still we have to give this passage. We didn't give our model. So whenever we ask a question, we try to find irrelevant information from reading paragraph. So let's ask a question. Okay, let's reduce this to okay to we ask only one question. Let's put this question. So let's see the context. let's see what we get as a context. We find for this picture on the disadvantage number of rural area in the mix. So I think we already added a reading part. Where is that? Reading. See this. So the following can answer the question. Reading the following passage. So we already give the passage, so it can answer based on that. So our context is correct. So answer the following question from our chunk. So this is the passage. So the model can answer it based on this passage. So let's see. I don't know, the provided context is cut off after the first sentence. Reading passage so doesn't contain info. So we have to check this. What the question was? Question was about if then. Where is the question? Question is, people who live in a city can get medical service. So I think there's the advantage, disadvantage, and there are yes, and people living in a city can get village rural health, but we can check. Can and all the people who, okay, let's add this part. I think we missed this part. People in city can go village, so but it's correct. So we have to add this part. We have to improve our context size. Let's make this one 800, this one 300, and let's run all. So now we have more broader context size. Can find rivaling part. Still, it couldn't understand what we are asking about. What we do, we have to improve our this in number of results. So can find rivalent documents for these. It's only provide passage that there is access medical care in Alberta, medical content, so there's something like that. I think it's text from this part. Access to medical care, moreover, compared to rural areas. So this is how this works. So we can ask other question too. Why the people who live in urban suffer from rural? Let's ask this question too. So reasoning from the case, the passage to the site, the environment is polluted with gas with okay, so this is a correct answer from I think second paragraph. I think this from this part, this area. So this is how can work with a big tickets for chunking and drag system. So next part we go to more advanced parts like PDF loading. So we take these books, we take these full books, and we use it. Also we add a source citation, so you can see that on Gmail whenever you upload a PDF and attach it. Whenever you ask a question, there is a site in the metadata about the where is the where it gets the context. So we can do and the metadata and the re-ranking. So this is so important when we get a new documents and conversation memory and tool calling. This is what we use every day and what we see on ChatGPT every day on Gemini. So We see these things in the next part. So this is what we have to understand the RAG, how it's work. So this is so basics, and I think simple to understand. And I will see you next tutorial. Bye bye. Hey guys, welcome back to this tutorial. So this tutorial we're gonna build a RAG agent with Chrome and Qwen. And what we do today, we try to last tutorial we did on RAG on a text, but in a real world we use different data from a PDF, from text, from documents. So in this tutorial, we're gonna see how we can, how we can take the, any documents or any text file or a PDF. So specifically, we try to do RAG from text and PDF file. Plus, the main thing is how we can add to metadata like source, citing the source whenever the model give answer any question. Also, it give us a site or cite the source where it find any information to answer this question. So this is so important, and we see currently on ChatGPT, every time I answer some question, cite the sources, like it may cite any websites or something like that. Or when you give a PDF file and when ask about the question on PDF, and when it give answer, it cites where the source is. So we do that on this tutorial. So we have to prepare two files. You can create a text file from anywhere. So I created from BBC page, from today BBC News. So I collected and I created a text file. You can do on a notepad easily, and I prepared my CV. So you can have for PDF. I have my CV. So we have to upload both of them. So first, let's install Chroma and OpenAI. Here is my text file. And let me upload from document my resume too. So I do have two files, so we can look at them. We have here is my resume. Let's see what's it look like. So this is my resume PDF. So this is one of the file I used to RAG, and I do have it. This is news text. Let's see on Notepad. So this is just copy paste from BBC web page. So this is just BBC web page news. So this is a raw news. So we can try on these two files. So we have to import necessary package. Then we have to define our client season and chroma too. So there is no new thing. It's just every time we have to define this thing is just this is the path where our file is saving. So you can find it here, ChromaDB, and this is the collection name, my agent, my RAG collection. So Just you can find this Chroma SQL i3, and this is a chunk. So already we know this, how this function works. So we use this to split or to chunk big files. This is indexing file, so we have to uh, carefully see this part. So what did this file do? Just try to open the file and then just try to chunk it, and then there is three lists. The first one is document, then IDs and metadatas. So in this loop for IND chunk and enumerated chunks, so this is to create a ID, and metadata we take for metadata source and the chunk. So this I is just our chunk ID. Can be if we have a 10 chunk file, we can have 0 to 9. So that kind of thing, and we use as a chunk ID, and this is a source of the file path. So our file path is this one. Will be a source of file path, and we add this as a metadata. So when the model answered the question, cite the source. So this metadata help us for that, and we add this on our collection. So we have to add on our database. So here is our document. So our document is our chunk, and ID is ID of our chunk, and then metadata. So this function indexing file function does these things. Let's see how it work. What we do, let's see. Chunk, and this was it's trying to just read, and then I think this part is not, it doesn't need anything, but let's see how it look like when we read the file. So can take this one, copy paste, and file path is equal to this one. Let's see. Let's see what that will look like is. Here is our text. So what we do then, we chunk them. Let's try to chunk our text. So when we chunk it, we get this kind of thing. So let's see. For instance, let's see the first chunk. So this is our first chunk. So whenever we ask any question, for example, if I'm asking about Middle East and Iran or Israel attack, like here is let's talk about 120 stuff Lebanon. So when USA and Iran, this kind of similar prompt. When I ever ask the question, when I give a prompt like this, try to take this kind of chunk as a context. So we have to understand that one. This thing is, so let's try to see how many chunk we have for this text. We do have 46 chunks, so we have 46 chunks we give as a context from this database. So we have 46. So we don't give this all 46. We just take one or two or three for each input. So this is then we try to loop on this, so in 46, so we get a ID and sources the same for all. So we have one path only, so there is one unique value for sources. So already we add on our collection database, so it will be stored there. Then this is just retrieving context, so we know this. Just we try to take the best answers or the best context for our question or for our prompt. So in default, we are taking 3. So we can change these numbers with others like maybe 2. So sometimes when we improve, when we have a large end results, just the model may lose the context, maybe adding more noise, and the model may make a mistake. So, and sometimes when we give a small, we may lose uh, some context. So we have to find the best value for this. That's up to you. And we take the best into result, and then we do take two things. Just document is our context, and metadata is our file path, where the file is coming from, and this is a context block. So we take both document and the metadata, and we append our context block, and we give for models. So let's see this part. Whenever ask a questions, sticks the questions, and uh, first we have to okay, call this function. So it takes only file path, so we can easily call it. Just let's give this let's copy everything and paste these things there. So finally, when we did it, we have 46 chunk for this, and our file path is content slash news text dot tks. So we can try to check something housework. So let's try to what's new thing on mm, uh, the USA. So let's try to find the best chunk for this question. So it could find this kind of thing. So you may have two. So we take the first one. Let's see the first one only. Okay, I think. And result is 2. So okay, it's not on list. I think I know. Okay, this is not a list. So this is our context is what we get for this prompt. Is if we change this prompt, we get a different chunk. So for this time, we get a chunk 21, and next one is I think chunk. Okay, chunk 0 and then chunk 21. So these two files is most related chunk for our prompts. Let's change this to export. Okay, we get this one, 36, that is missed, put in the hotel. So this is talk about the football, and the next chunk is think chunk 2. So these are, so how the, just this is as our prompt is when we ask, for example, Gemini, just when ask something about anything, just when what's new with ball, just Gemini do the same thing. So takes try to find any information. It may use different tools. We have talked about the tools, so it may use a Google search or API news. It may try that kind of thing. So this is just like RAG. RAG is the same thing. So we are taking information from our database. So we can go to next part. This function ask RAG, just this is we are asking a model. So here what we are doing, we take the context part from retrieve context. That means from this one, this function is just whenever we take a question or a prompt is and get the best context, this like this one, and then here is this is a system prompt. We are just giving instruction how the model could act, and then we have a prompt. So this is our prompt. So two things, we have context. That means we get from our document or from this news, or pasted 2 or 3 chunks based on our question, our prompt is based on our this question. So this question is just what we give for models, what we ask. So here is the model. We are calling the models here. So we are using this model Qwen 3.6 Flash, and here is we are just giving the system prompt and user prompts, and I defined 300 max lowers and temperatures 0, and then we get this response. Already I thought we have seen this thing is how the model response. We should extract the answer part. So you can look at the first part, how you can build the AI agent from scratch. So in that tutorial, you can, you know, you can understand how the models and response look like. So you have to go and watch that tutorial so you can understand it. So let's try to so we don't have to these things for now. Already we did it. We don't have to. So let's ask about what's new on run. So based on a provided document, the USA and Iran are currently exploring draft peace deal. This development has also contributed to cooling global oil prices. Cooling. So this is cool, and what's happened on this part today? So I think the main thing is just when we ask this is our question, and then here is the source of our course is this is a file path, and it means just the chunk's number of no chunk ID, and here is the answer for the next question. The USMA national team recap squad reveal prompted actions regard key winners and the losers, basketball, wrestling. So this is based on the text file, we can find them. So this is how we can build RAG from text file. Next, what we see, let's call this one. Yeah, I think we may square. Let's exit this. And next, what we do, just try to build drag from PDF file. So let's see. Most of the time we use a PDF file. So this is so important to build drags or AI agent. So just this is the same thing. We do the same thing. Just we create a new Chrome database. So the name is different. So PDF drag collections, and our chunk size and overlap is I have changed. I have improved, increased the number of chunk size. So there's no the new thing is, and then what we do, just let's see how look like the PDF. Let's see. Let's read this. Here is just we are using PDF readers. This is the file path, and let's see when we check this PDF, we see this kind of thing. So this is just the file. Let's try to extract anything from this one. So I'm trying to explain this function. So take a file path or this file path and then read, and then try to take page number and text. Page number and the page, just the page text. So just try to enumerate on this or a PDF file. So what it does, just text is equal to page dot extract text. So how we can do that? So we can do on for loop. Let's see. For I let's say page number, page, sorry, page number and page, and enumerated PDF. So we can say this. So taking this PDF file and dot page. So let's see what look like with the page PDF dot page. So it looks like this kind of thing. So let's try to print. So text is equal to page dot extract to text, and page number is equal to page number, then text. So this is a big file. Let's start from here. Let's come here. So this is page one. It's actually at the server. This is a copy part, and so you have a file this like, and so we have a page numbers and our text. This is page number. This one is text. So next, what we do, we try to you know, save this to page and or page text and page. So this function does this thing is, then let's extract our page. Just this is a path what we give, and let's see page 0. That means the first page, and the text was how it look like. So this one is the page 1 and the text, and let's see page 3. This is last page, and this is a page 2. So we have this kind of thing. So let's see on page. So we have this kind of thing. So page and the text. So whenever we ask, this is a page. Let's see page. So the first one is 1, then we change this to this is the last one, page 3. So we have a 3 page. So we collect this thing is here. So this page file variable collect all these things. So next what we try to chunk. So this indexing function does that. So try to read our PDF from this path and then extract and get this page file. So these things we did it there, and then try to collect metadata ID in a document. So this three thing is what this is our just the text thing, and this is ID for them, and this is metadata. So in metadata we collect source, that means file path, and page, a page number, and chunk index. So we collect three things and we loop on page. So we take the page and page text. This is a page number and the page text. For each page we have a text, so then we try to chunk them. We have to chunk page, so we don't take one page as a one chunk, so we can do that. So because it's big, we have to chunk them to get better result, specifically to get the best paragraph from the page. So based on our questions, so we do that. So let's try here. We take a page, first page, and we try to chunk them. We try to chunk it, and let's see. Okay, here is a chunk. So let's see how many chunks it created for page 1. For page 1, we have created 7 chunks. So let's see the first chunk how it's like. So let's see the first chunk. This is here is a first chunk, and we can see there is some overlap. So when we see, we can find this thing is because we are overlapping, so we can find this part. So we do this and save here. Just we take the chunk, we are looping on, we did a chunk here on a page, so we are looping on each page and then try to create a document ID on file path and page number and chunk index. So we create that thingy and then save them, and we add on our collection. So this function does these things. Let's try to index, and let's go to next part. We give only file path. We require only file path. So we know that our file path, we are working on PDF. So take the PDF files and copy path. So we have a certain chunk from this PDF. So we have a certain chunks, and we have saved on our collection vector database. So next part, this one is just the same thing. There is no new thing here. We take n result 4. So our default value is 4. We can change. This is 2 is enough. I think 3 is enough. We take top 3 value. So we are taking a source, just get source and page number and chunk as a metadata. So when the AI model answer a question or question for our question, it should give a source, page number, and a chunk. So this is how citation work. So take these three things: source, page, chunk. That means our context. So source, page, and chunk plus document. So let's go to the next thing. So this is not new thing. We can check this. We can check this one. Let's try to ask one question about our CV. So I can ask about my sorry. So what we ask about myself. What are main scales? We get three chunks. So let's see the first part, the first chunk. So I think this it's not a list. So the first part is source is the same. We get one file. When we have a lot of PDF file, it may be different, but page is 2. We have 3 pages. So from page 2 and chunk number is 2. We have a certain chunk, and next source is I think second one. So here is page 1 chunk 6, and so this is work like this. So next let's try to ask a model. So we are asked here, this is this functional to ask, and already we did it. We ran this thing is, so we only ask question. Let's try. What are main skills? We are asking a model, so we got this answer. Programming language, machine learning. So this is a correct answer. Can refer and check it. And our source is, this is a file path and this is a page name. So great. So this is how we can build RAG from PDF file and how we can cite our the source. And we did on PDF and the text. Next part, we try to build a web app. So like clone like a Gemini or ChatGPT. So we try to include all things, a tool calling, RAG. We build RAG on a PDF, text, documents, and also on our chat history and a response to. We have to collect all them and we have to re-rank them, re-ranking them. So we do that in the next video. So it will be a big, this will be a long, and it's a complete, it's gonna be a complete, just real application. We're gonna deploy everything. So we will have a great tutorial in next one. So thank you.